I'd like to talk to you about solving one-step equations. We'll also solve two-step equations and multi-step equations. This is a review from Algebra 1 and also some skills that you've used in geometry. So these examples should be familiar. To solve any equation, you need to use inverse operations. And that just means that we'll undo whatever's been done to the variable. For this first equation, x plus 3 equals 9. Since I added 3, I'll do inverse operation and subtract 3. 3 minus 3 is 0, so I get x plus 0 on the left side. I'll just write x. And on the right side of the equation, I get 6. To check yourself with any equation that you solve, you can substitute the value that you find in place of the variable. And then we just need to make sure that the equation is still true. Is 6 plus 3 equal to 9? It is. So our solution is correct. This will work for any equation that you have. I can also solve for m. Negative 5 plus m is 10. If I add 5 to both sides of the equation, on the left I have negative 5 plus 5, that's 0, plus m, so I have positive m equals 15. And I can check that. When you have fractions, fractions are division problems. So here, this just means to divide. I could rewrite this equation as y divided by 4, if you prefer to look at it that way. But these are equivalent, the y over 4 and the y divided by 4. Either way, I would multiply by 4. That would be an inverse operation. So that leaves me 4 over 4, which is 1, and y. And on the right side, I have 8. And again, I could put 8 where the y was. 8 divided by 4 is 2, so it checks. When numbers are right beside each other, they're multiplied. And I'll use a capital B. If you use lowercase b's in your equations, you need to be really careful about having neat handwriting so it doesn't look like a 6. 3 times b is 18. Some of you can just look at this and know what b needs to be, but we'll follow the process and do an inverse operation. Opposite of multiplication is division. So I'll divide by 3. And I'll divide 18 by 3 also. And I get b equals 6. We'll also solve two-step equations. Oh, there's a scribble here. Sorry. To solve two-step equations, we'll add or subtract the constant first, and we'll multiply or divide the coefficient next. When you multiply or divide, do not change the signs. So if your number that you're multiplying or dividing is positive, then you will multiply or divide whatever's opposite, a positive number. If you are multiplying or dividing by a negative number, then you will do the opposite and with a negative number. Just keep the sign that it has. For this first problem, I have positive 2x plus 3 equals 15. First, I'll add or subtract. So I have positive 2x plus 0 equals 12. These are multiplied together, 2 and x. So I'll divide by 2 to get x. I also need to divide the 12 by 2. 12 divided by 2 is 6. So I find that x is equal to 6. I can check that by putting a 6 here. 2 times 6 is 12, plus 3 is 15. For this next problem, I will first add 4. I'll have 2x plus 0 equals 7, and divide by 2 to find that x equals 7 over 2, which is a fraction. Don't be concerned if you get a fraction. My rule for fractions and decimals is if you can write a fraction as an exact decimal and not round, then it's fine to write it either way. If you have to round to write a decimal, then just keep the fraction. So let's make a note of that. Decimals, oops, wow. Okay, I'm having that day. How about this? Decimals, okay. If they're not rounded. So this is my rule. If they have to be rounded, then we would just keep the fraction. I'm not sure how comfortable you are with fractions, but we will use fractions a lot this year to hopefully get you more comfortable with them. Negative x minus 6 equals 7 is our next problem. I will add 6 and get negative x plus 0 equals 13. And you can think of this as negative 1 times x, or you can think of it as x divided by negative 1. We're going to consider it multiplied. To change this, you can multiply by negative 1 again, or you could divide by negative 1. Either way, we really just change the sign and put the negative on the left. We find that x is equal to negative 13. For this last problem, for two-step equations, first I will subtract. You don't have to subtract. You could divide first. If you do that, you need to make sure to divide every piece, which will give you negative 6x over negative 6, and 1 over negative 6, and 3 over negative 6, and then you can add and subtract. Many people would rather not create fractions for themselves if that's not necessary. So that's why I give you the order of add or subtract first. And then multiply or divide. These are multiplied now, so I'll divide. This is negative. I won't change the sign. I'll have to divide by negative 6. What I get is x is equal to negative 2 over 6. I can put negative 2 divided by 6, are 2 divided by -6, or put the negative in front and have 2/6. All of those are equivalent as long as the negative makes it to your solution. This is a reducible fraction. To reduce a fraction, you divide the numerator and the denominator by the same number. I chose 2 because they're both even numbers, so they're divisible by 2. This then would reduce to be -2/2 is 1, and 6 divided by 2 is 3, so I get -1/3. And this can be checked. This problem, or this solution, I could not write as a fraction because of my rule. This is 0.333 repeats. I would have to round or truncate to write as a decimal, and since it's repeating, I'm just going to keep it as a fraction. We have steps here for if there's more than 2 steps to solve an equation. Whenever you have parentheses, we'll use the distributive property. I will distribute so that I can take the parentheses off. Both of these terms are multiplied by 5. So I can write this as 5, which is 5 times 1, plus 5 times 4x is 20x. And then I'll subtract 2x, and that is from here. That's not from distributing, that's because that was already part of the problem. I'm just bringing it down. Next, I combine like terms. These are like terms. They both have x. 20x minus 2x is 18x. 13 and 5 are both constants. To move variables to one side of the equation, move constants to the other side of the equation is the next step we would take. I have the variables combined on the right side, so I'll move the constants to the left side using inverse operations. This is a positive 5. If I subtract 5 on the right side and subtract 5 on the left side of the equation, what I have is negative 18 equals 0 plus 18x. Now, I use inverse operations. I need to move this. I just did add or subtract. Now I will divide or multiply. These are multiplied now, so I'll divide by 18. And I find that x is equal to -1. Again, you can always check your work with equations by substituting your value that you find for the variable. Whoops, sliding. Please use parentheses when you substitute. So I need to know if 5 times 1 plus 4 times -1, 5 times, this is -4, we do the parentheses first. -4 plus 1 is -3, so this would be 5 times -3. Wow, which is not what I wrote. Minus 2 times -1. I'm subtracting a negative. 2 times -1 is -2, but I'll subtract -2. When you subtract a negative, you add a positive. This gives me 5 times -3, that's 15, plus 2. Oh, sorry, -15 plus 2 is -13, so it checks. Please work this last one out on your own. Pause the video, and I'll put the answer up here once you've worked it out so that you can check yourself. I finished working out the last problem, and I found that x is equal to -1. Here, where I distributed first, make sure when you distribute, if your number that you're distributing is negative, that you also distribute the negative sign. Then I combined like terms on the left, and then I started moving variables to the same side, moving constants to the same side. I found that -47x is equal to 47. I divide by -47 on both sides, and I get x equals -1. You can substitute back into the original equation if you like. Make sure that you go all the way back to the original and put in -1 for each x and verify that the equation is true. This has been our solving linear equations review.